Hi, my name is Gia Susan John. I'm currently a senior at Cumberland Valley High School, and my research was focused on the role of ferroptosis inhibitors in neurodegenerative diseases, treatment, and prevention. So for an introduction, my research was focused on the scope of neurodegenerative diseases, which affect nearly 15% of the global population. And these diseases tend to stem from molecular or cellular aggressions, including protein aggressions. And some of them are many of them are linked to apoptosis, which is a form of programmed cell death. And a specific type of apoptosis that has been growing within research and has been recently identified is ferroptosis. And ferroptosis is a form of programmed cell death that is linked to the overaccumulation of iron and lipid peroxides. So the occurrence of lipid peroxidation is directly linked to ferroptosis because it can cause the destruction of the cellular membrane. And ferroptosis has been linked with neurodegenerative diseases because in a study that was conducted on over 300 Alzheimer's patients, they found a similar accumulation of iron levels in their cerebral cortex, which indicates a link between their neuronal death and also the iron levels. So for my literature review, I focus more on iron metabolism and functioning. So the presence of iron in the human body is vital for various physiological functionings, such as metabolism and cellular formation. So there are two main forms of iron present in the body, ferrous and trivalent iron, which is Fe3+ and Fe2+. And trivalent iron is the most common form present within the body. And ferroptosis is linked with the overaccumulation of the lipid peroxides. So since ferroptosis is still a newly forming a concept, there wasn't a lot of research conducted on exactly how it was linked with Alzheimer's or neurodegenerative diseases, and most of the literature focused on current models and studies that were conducted on mice or cellular models of different diseases and how that could be linked to iron accumulation and functioning. Many of the mice models were conducted on mice that had spinal cord injuries. For my methods and results, I analyzed and collected studies that were predominantly conducted on cellular models and mice models. And these studies were found on websites such as clinicaltrials.gov and and Frontier and NIH. So one of the main forms of inhibitors that I identified was ferrostatin 1, which is a molecule that inhibits lipid peroxidation faster than any other by selectively inhibiting arachidonyl PE oxidation. So ferrostatin was found to inhibit lipid peroxidation, which is directly linked to ferroptosis, as previously mentioned. So this molecule can inhibit lipid peroxidation and thus can slow down and inhibit the process of ferroptosis. And similarly, it was viewed in a Huntington's disease cellular model as to inhibit lipid peroxidation, which ferrostatin was done, which they used to identify the role of ferrostatin. Another inhibitor that I identified throughout my course of my study was GPX. And GPX is one of the 8 forms of glutationic peroxidase. And those are one of the 8 models that are identified in mammals. And a final form of inhibitor was vitamin E, which was identified as to minimizing the progression of lipid peroxidation in their cellular models and also the mice models. Although the concept and the formation of how vitamin E was not widely discussed or is unsure of, it is identified as to slowing down the formation and the destruction caused by lipid peroxidation. So, though my studies were mainly conducted on cellular models and mice models, further research could identify how these molecules can provide a greater understanding of how it could be used in more pharmacological uses and treating neurodegenerative diseases as a whole. And since it's a growing topic, there aren't direct links fully developed in order to examine how it could be used in direct treatment or prevention. As of now, most of the research that I found was mainly focused on hypothetical links and also with links focused on how iron accumulation is prevalent within neurodegenerative diseases. That was one of my weaknesses of my study, as since most of my studies do not focus on the direct link, further research could be exploring on specific diseases as well. Since neurodegenerative diseases encapsulate a wide range of diseases, most of my studies focused on specific diseases such as Alzheimer's or Huntington's. Thus, the effect of ferroptosis and their inhibitors on different diseases could vary widely. I would like to thank my professors, Dr. Dr. Varkey and Professor Virgil. And this experience was very enlightening for me as I learned the process of conducting a research study on my own. And through their one-on-one sessions, I was able to identify how I could explore this topic. Since I liked the concept and I enjoyed the area of study, but I really struggled since it was a more niche concept that was still growing. I struggled to find studies that pertain to it. So through Dr. Burkey's help, I was able to identify how I could explore this topic more in depth. And Professor Virgil really helped me with organizing my paper and understanding how I could format it.
Wonderful. You want to stop sharing, Gia? Yeah.
Good job on presenting. And also, I know that you have in that study connecting different molecules with ferroptosis. So a question for you. So since ferroptosis is nothing but like apoptosis in a specific way, how do you think, like, is apoptosis important for the cells since eventually the cells die? Do you think it's important in general? Is it required by the body?
Yeah, I think apoptosis as a whole is important in making sure that, like, I guess cells that are destroyed or survive minimally aren't affecting the normal processing of the body. But I think since most of these Alzheimer's are linked to like neuronal damage and then specific areas of the brain, preventing these or inhibiting such processes from occurring can not fully like prevent the disease, but could delay the onset or the progression of the disease.
Good answer. Good job. So continue to expand upon your knowledge, and then best wishes for your future too.
Thank you.
Awesome. Great job, Gia. Thank you.